Hello, and thank you for joining us for our application video for environmental samples. Soil is one of the most common matrices to be analyzed for contaminant compounds. These compounds are regulated due to their adverse health effects on people and must be monitored to ensure the safety of both people and the natural world. Today we'll be extracting samples for semi-volatile organic compounds, or SVOCs for short. These compounds have a broad set of chemical properties and structural features, which can make their extraction difficult. Traditional methods of doing this extraction can be time-consuming and labor-intensive as well. The EDGE provides a vastly improved method for extraction that is both quicker and simpler than traditional methods. The EDGE provides consistent and even heating, as well as inline filtration of extracts for an all-in-one sample prep system. Let's now walk through programming the method on the EDGE. We first name our method and select the QDIS that we will use. In cycle parameters, we program in our solvent and addition. The first cycle has a volume addition of 15 milliliters at a set temperature of 70 degrees Celsius. The hold time at temperature is 30 seconds. The second cycle is the same as the first. Cycles 3 and 4 have the same parameters, except for temperature, which will be at 100 degrees Celsius. Lastly, we are going to program the wash. Like the cycles in the method, the user has full control of wash parameters as well. A wash is done after every sample to ensure a clean, fluidic pathway. Next, for sample prep, the first thing we're going to do is assemble the sample holder, the Q-cup. The first thing to do is to place Q-disc into our Q-cup base. The Q-disc is the inline filter we have for the Q-cup. We will be using the S1 stack, which consists of a glass fiber filter supported by 2 cellulose filters. This Q-disc has a porosity of 0.3 microns, which is suitable for any kind of analysis. We then assemble the Q-cup by screwing together the body and the base. The single thread design makes it simple to assemble and clean. Next, we will weigh in the sample. The Q-cup is made of lightweight, hard anodized aluminum, so it can be placed directly onto an analytical balance. For these samples, we recommend no more than 30 grams of sample, and not to exceed the outside band of sample capacity. If sample contains moisture, mix sample with sodium sulfate before weighing into the Q-cup. At this point, any internal standards or surrogates can be spiked into the Q-cup. A 2-gram bed of fluorosil will be added to cover the sample. This will keep the low, volatile compounds from evaporating. Insert a Q-screen into the opening of the Q-cup and push it down with the Q-screen tool. This screen helps to keep samples submerged in solvent and keep the inside of the sample chamber clean. Now, the Q-cup is ready to be placed in the rack along with the collection vial. Today we are using our clear 60 ml glass collection vials. With our sample in the rack, let's go ahead and load the rack into the edge. The rack is held down by magnets, which lock it into position. Select the method we programmed and load it into the position. Press play, start, and let the edge run. The automation will load the Q-cup into the sample chamber in the rear. The autosampler will then move into the collection position above the vial, as the seal head comes down to close the chamber. The seal head then adds solvent, and the heater heats the chamber and sample to the programmed temperature. From then, the unit holds until the program time is elapsed. After the program time is elapsed, the edge will then collect the extract. After the initial collection, the edge then purges the sample with the built-in pump. After the purge, the edge then removes the sample from the chamber, places it into the original position, and then moves to the washboard to begin its wash. The extract has been filtered and cooled. After extraction, the extract is ready for concentration in an evaporator. Before placing in an evaporator, the extract will first need to be poured over sodium sulfate to remove any water. We can now transfer the extract to an evaporator to concentrate to a desired volume. After an appropriate volume has been reached, transfer to a GC vial. We will now load the GC vial and run an appropriate GCMS method. In just a short while, we will have our analytical data and will be able to calculate our percent recovery. Acceptable recoveries and RSD values were obtained. Thank you for viewing our virtual application note for semi-volatile organic compounds in soil. For more information and to access the actual application note, please visit CEM.com.